is a radian? Well, a radian simply is a unit of measurement for angles. If you look at the circle on the left, we've broken down the circle into degrees. That's a unit of measurement that's probably very familiar to you. Remember that there are 360 degrees in a circle, and so that makes 1 degree a very small angle. Now, notice the circle on the right. The markings are in radians. And notice that 1 radian is a lot bigger than 1 degree. Also, in a circle, if we create an angle that does a full rotation, there are 2 pi radians in that angle. Now, how does that work? Let's look a little bit more closely at the definition. So the technical definition of a radian is that 1 radian is the measure of a central angle that has an intercepted arc equal in length to the radius of the circle. What the heck does that mean? Well, think about it this way. If you start walking along the outer edge of the circle, let's say you start right here where your circle hits the positive x-axis, and you walk around the outside of the circle, and you walk a distance that's equal in length to the radius, you have just created an angle of 1 radian. So that's the definition of a radian. Now you can keep on going with this same theme. So walking 1 times the radius creates an angle of 1 radian. If you walk 2 times the radius in distance, so 2 times the radius, you will create an angle of 2 radians. Likewise, if you keep on going and you walk a distance equal to 3 times the radius, you're going to create an angle of 3 radians. And you can keep on going the same way. Now, how do we end up with 2 pi radians in a circle? So let's make a little chart. We see that if we walk a distance, of 1 times the radius, whatever that is, it could be 5 inches or 20 miles, whatever the radius is. If you walk a distance of 1 times the radius, you've created a central angle of 1 radian. If you walk a distance of 2 times the radius, you've created an angle of 2 radians. 3 times the radius in distance around the outside of the circle, you've created a central angle of 3 radians. So if we keep this up and we walk a distance all the way around the outside of the circle, how far is that? Well, remember that the circumference of a circle is 2 pi times the radius. So if we walk a distance of 2 pi times the radius, then we've created an angle of 2 pi radians. So 2 pi radians. And remember that pi is just a number. It's 3.14 with a whole bunch more digits. And if we wanted to, we could get an approximate number for the number of radians in a circle. Multiplying 2 times pi, you would get approximately 6.28 radians. But we tend to keep the pi in there because we like to deal in the exact answer rather than rounding something off to get an approximate answer. Now let's go back to our original circle, and we've seen how we get 2 pi radians in a circle. So all the rest of these angles that are marked on here you can derive from just knowing that. If you walk a quarter of the way around your circle, or in other words, if you take your terminal side of your angle and rotate it a quarter of the way through your circle, you know that a full rotation is 2 pi radians, so a quarter rotation is going to be pi over 2 radians. And notice also that that is a right angle. So pi over 2 radians is the same angle as a 90-degree angle. If we go half a circle, so now we create an angle that does a half rotation, we have pi radians. So remember, all the way around was 2 pi. Divide that by 2 because we're only going halfway. We get pi radians. And you know from experience with degrees that that is the same as 180 degrees. Keep on going. Now you're 3/4 of the way around. So if you take 3/4 of 2 pi, you get 3 pi over 2 radians. And then, of course, you're back to the beginning where we have 2 pi radians in a full rotation, and that is the same as 360 degrees. Now let's take a quick look at our conversion. You've already seen that 90 degrees is the same as pi over 2 radians, and pi radians is the same as 180 degrees. And in fact that pi radians is equal to 180 degrees is really all you have to remember, because from that you can get to the conversion factor to convert from radians to degrees and degrees to radians. So let's say that you have a number of radians and you want to convert that to degrees. So we take our known fact, pi radians is 180 degrees. Now we want to know what is 1 radian. So divide out the pi. We get that 1 radian is equal to 180 over pi degrees. So there's your conversion factor for converting from radians to degrees. We're going to do a very similar thing to go from degrees to radians. So again, start with that one known fact that you remember, 180 degrees is equal to pi radians. Now we want to know what 1 degree is equal to. So 1 degree is equal to pi over 180 radians. So there's your conversion factor for converting from degrees to radians. And again, as I mentioned before, normally we leave pi in. We don't convert it to 3.14 because we would like to deal with the exact answer. So leave pi in for the exact answer. If you're asked just simply for an approximate answer, then you can go ahead and you can divide with the pi being 3.14 and round off to whatever decimal place is required, and you'll have the approximate answer.